Assalamualaikum. My name is Muhammad Shukri. So today we're gonna do our discussion about our progression for mini project electrical technology. So I will share you my report that I have done a little bit. So you can see.
Yes.
Yes.
So for the report we're gonna do for mini project is grid connected PV system. So for the introduction, a grid connected photovoltaic system or grid connected PV system is an electricity generated solar PV power system that is connected to the utility grid. A grid connected PV system consists of solar panel, one or several inverter, a power conditioning unit and grid connection equipment. They range from small residential and commercial rooftop system to large utility scale solar power station. Unlike standalone power system, a grid-connected system rarely include an integrated battery solution, which they are still very expensive. When conditions are right, the grid-connected PV system supply the excess power beyond consumption by the connected load to the utility grid. So this is the system configuration. So residential grid connected rooftop system which have a capacity more than 10 kilowatt can meet the load of most consumer. They can feed excess power to the grid where it is consumed by other user. They range from small residential and commercial rooftop system to large utility scale solar power station, unlike standalone. So when the condition are right, the supply access beyond the consumption. So that's a little bit for our report for this mini project. So can uh, Ikram show your simulation or progression
Yes.
for this project?
Yes. Thank you, Shukri. So this is my work. This is what I and Harit have done for this mini project. This is only partly what we have done because it's not fully finished yet. Okay, first we have to add the primary load, the converter and PV to the circuit. Then we have to change the load kilowatt for every hour of the system. For from 12 to 1 a.m. it's 1.4 kilowatt per hour. Then it decreases to 0.9 and it decreases more at 2 o'clock to 3 o'clock to 0.6 kilowatt per hour. Then it remains the same at 3 o'clock from 2 o'clock until 5 o'clock. It remains at 0.6 kilowatt per hour. After 5 o'clock, it increases to 0.9 kilowatt per hour. Then it continues to increase to 2.1 kilowatt per hour at 6 to 7 a.m. Then it reduces back at 7 o'clock to 8 o'clock to 1.6 kilowatt per hour, and it continues to decrease to 1.2. Extend at 1.2 until 10 o'clock in the morning. After that, from 10 to 11, it increases to 1.5. 11 to 12, it increases to 2.3. For the next thing, I will to Harit to explain.
So for 12 to 1 p.m. 1 p.m. o'clock, it is time at 2.8 kilowatts per hour. then it is decreased to 2.3 kilowatt per hour at 1 p.m. to 2 p.m. Then it decreased to 2.2 kilowatt per hour at 2 p.m. Until 3 p.m. Then until from 3 p.m. to 4 p.m. it increased to 2.3 kilowatt per hour. Then for 4 p.m. until 5 p.m. it increased to 2.8 kilowatt per hour. And for 5 p.m. to 6 p.m. it increased a lot from 2.8 to 4.4 kilowatt per hour. At 6 p.m. until 7 p.m. it also increased to 5.7 kilowatt per hour. Then at 7 o'clock it also increased to 6.2 kilowatt per hour. At time 8 o'clock it decreased a little bit to 6 kilowatt per hour. And for 9 p.m. it decreased for 5.4 kilowatt per hour. At time 10 o'clock it decreased until 4.3 kilowatt per hour. And for 11 o'clock it also decreased until 2.8 kilowatt per hour. So that is for the primary load inputs that we done for the load. So that's all for the simulation.
Next, we give it to
Next.
Muhammad Syami.
Okay, thank you Ikram and Harith for showing. So now me and Nasrullah will show you guys our simulation. So as you guys know, can you see?
Yes.
Yes.
Okay, as you guys know that Nasrullah and me, we are doing for the Delhi, India. So we also have done the simulation as you can see here. And then for the solar resource, I have already put the value and the value that I get is from our lecturer, madam, which is the Gaisma here. So as you can see for the month of January, the clearness index for January is 0.560 and for February 0.6, in March 0.63, also in April 0.64, and then the number decrease in May, which is 0.3, and then in June the number also decreased to 0.56, and also decreased in July, which is 0.449, and also decreased again in August 0.47. Then it increased back to 0.56 in September. October the number is 0.62, and in November is 0.64, and December is 0.59. So the average for the whole year is 0.578. So for the daily radiation, I will hand it over to Nasrullah.
For the daily radiation in January, 3.435 kilowatt per day. In February, increased to 4.403, and in March, 5.604, and to April it increased to 6.578. In May, it increased to 6.991 kilowatt per hour, and in June it decreased to 6.370. In July, also decreased to 5.490. In August, also decreased to 4.954. And in December, it decreased to 5.230. In October, decreased to 4.8022. In November, 4.089. And in December, 3.391. For average, 5.114. Okay, Syamil.
Okay, we also currently me and Nasrullah also searching for the price for the converter and also PV. The value for value for the value it charge for every 1 kWh. That is all, Shukri, for our submission.
So for this task 2, we just end because we just show our progression for mini project. So we can end this session. So we can proceed to the uh, video number 3 for our final result. So thank you for today.
Thank you.
Thank you.
Right, so
Thank you
thank
all.
you.
Thank you.